On a warm monsoon evening, Qubit watched a silver flash stitch across a dark cloud. 1 second, 2 seconds, 3, boom. His antenna sprang straight up. Did the sky drop a giant steel cupboard? Not quite. Thunder is sound made by lightning, but the journey from a thin flash to a room-shaking rumble is wonderfully dramatic. Inside a tall storm cloud, rising air carries tiny ice crystals upward while heavier hail-like pellets fall. Their collisions help separate electric charge. Different parts of the cloud become oppositely charged, and the ground below can be affected too. The electric field grows stronger until air that normally insulates electricity can no longer hold it back. A lightning channel then forms through the air. Charges rush along this narrow path in one or several brilliant pulses. Some lightning stays within a cloud, some jumps between clouds, and some connects cloud and ground. Qubit's first surprise: the glowing channel can be only a few centimeters wide, even when it stretches for many kilometers. The current heats the channel extraordinarily fast, to roughly 30,000 degrees Celsius for a brief moment, several times hotter than the sun's visible surface. The surrounding air has almost no time to move gently aside. It becomes fiercely hot, expands explosively, and squeezes the neighboring air into a rapidly traveling pressure disturbance. Very close to the channel, that disturbance begins like a shock wave. As it spreads and loses strength, it becomes the sound wave we call thunder. The air itself has not flown all the way from the cloud to your ears. Instead, neighboring air molecules push and pull one another, passing the pressure pattern onward like a stadium wave. Why can thunder sound like a sharp crack, a heavy boom, or a long rolling growl? A nearby part of a lightning channel sends a strong, sudden pressure change to you, producing a crack. More distant sections sound softer and later. Your ears combine these arrivals, so one crooked flash can create a whole percussion performance. Light and sound travel at hugely different speeds. The flash reaches your eyes almost instantly over storm distances, while sound moves through ordinary air at roughly 343 meters per second. That is why you see lightning before hearing thunder. The storm did not pause for dramatic effect. Thunder was simply still traveling towards you. You can estimate distance by counting seconds from flash to thunder, then dividing by about 3 to get kilometers. 6 seconds means roughly 2 kilometers. This is only an estimate because temperature and wind change sound speed and the lightning channel is spread out. Most importantly, counting is not permission to remain outside during a storm. Lightning is not a tiny point. Its channel can branch and zigzag through kilometers of sky. Sound from the nearest section arrives first, while sound from farther sections takes longer. Each part adds another crack or rumble. Even when you see one flash, you may be hearing many sections of its enormous, twisting path. The landscape reshapes the sound as well. Thunder reflects from hills, buildings, the ground, and layers of air with different temperatures. Those echoes and bent paths arrive at slightly different times. In a city, a boom may bounce between towers. In a valley, the same thunder can roll around the slopes like a giant drum. Low-pitched sound usually survives the long trip better than high-pitched sound. Higher frequencies are absorbed and scattered more easily, while deep frequencies bend around obstacles and travel farther. So nearby thunder contains bright cracks and snaps, but distant thunder loses much of that sharpness and reaches you mainly as a low, gentle rumble. Does every lightning flash make thunder? Yes, every lightning channel heats air and creates sound. However, you may not hear very distant thunder because its sound spreads, beacons, and is masked by wind or other noise. Heat lightning is not silent lightning caused by heat. It is usually distant lightning whose thunder cannot reach you clearly. Thunder itself is not an electric bolt, and it cannot strike you. It is evidence that lightning is close enough to matter. The dangerous part is the electrical discharge, which may reach well beyond heavy rain. A blue patch above you does not guarantee safety when a thunderstorm is nearby and charged regions extend around it. Never shelter under an isolated tree, inside a small open shed, or near water, metal fencing, hilltops, or open fields. If you hear thunder, move promptly into a substantial building or a fully enclosed hard-topped vehicle. At a cricket ground, beach, farm, or playground, do not wait for raindrops before leaving. Indoors is safer, but sensible precautions still matter. Stay away from windows and balconies. Avoid plumbing and unnecessary contact with wired electrical equipment because lightning current can travel through pipes and cables. Follow local weather alerts. Wait at least 30 minutes after the last thunder before returning outdoors, because another flash can arrive unexpectedly. Pets and younger children may find the noise frightening. A calm room, closed curtains, familiar company, and gentle reassurance can help. There is no monster inside the cloud, and the sky is not angry. The boom is a pressure wave telling the story of air heated too quickly by an immense electrical current. Scientists study thunder with microphone arrays, high-speed cameras, radio sensors, weather radar, and precise clocks. By comparing when sound reaches different microphones, they can map parts of a lightning channel hidden inside cloud. Thunder is not merely storm background music. It carries useful clues about where energetic electrical events happened in three-dimensional space. So here is Qubit's thunder recap. Colliding ice helps organize charge, lightning current races through a narrow channel, intense heat makes air expand violently, and pressure waves become cracks, booms, echoes, and rumbles. Light wins the race to your eyes. Sound arrives later. Qubit raised his microphone. Boom! Excellent bass, cloud, but next time, kindly warn my antenna.